This is section 11.4, matrix algebra, and the objectives that we're going to be looking at are: we want to find the sum and difference of two matrices. We're going to add and subtract matrices. We're going to find the scalar multiples of a matrix. We're going to take a number and multiply it into the matrix. Find the product of two matrices. We're going to multiply matrices together. We're going to find the inverse of a matrix, and we're going to use that to solve problems. Here we basically have a matrix where the numbers that go across, those are our rows. So we would have 1, 2, 3, in this case, possibly 4 or more rows. Notice the rows have this I in it. So this would be like AI, AI2, and so on. So the rows have the first number, it signifies the rows. So this would be row 1, column 1, row 1, column 2, and then the columns, those are the second digit, and then row 1, column J, row 1, column N, and so on. The columns, they of course work vertically, and they're symbolized with a J. So notice this would be A, I, J. The I signifies the row number, the J signifies the column number. Alright, so here this would be 2 rows by 2 columns. So this would be row 1, column 1, row 1, column 2, and so on. Row 2, column 1, row 2, column 2. This is 1 row by 1, 2, 3 columns, so this would be a 1 by 3 matrix. And here we have 1, 2, 3 rows by 1, 2, 3 columns. So this row right here, this would be row 2, column 1 is a 4. Row 2, column 2 is a 3. Row 2, column 5. Row 2, column 3 is a 5, and so on. And now we're going to take a look at sum and difference of two matrices. If we have two matrices, we'll call a matrix A and matrix B. If they're said to be equal, they would be written as matrix A equals to matrix B, provided that they have the same number of rows and the same number of columns for each. So if A was a 3 by 2, then in order for B to be equivalent, it would also have to be a 3 by 2 matrix. We can also say that matrices follow the commutative property of addition. If we take matrix A, add it to matrix B, that would be the same thing as if we took matrix B first and then added that to matrix A. Matrices also follow the associative property of matrix addition, where if we took the first two matrices, add them together, then add the third matrix, we could also add the second and the third, we'll call them matrix B and C, together first, and then matrix A, and you would get the same result. Alright, so if we have matrix A, and we're saying that matrix A has the numbers 2, 3, -1, 4, 0, 7. And we're saying that matrix B, that has -1, 2, 1, 5, -3, 4. And we want to say, alright, we want to say matrix A plus matrix B equals to what? So we're going to add these two together. So what we're going to do here is we take the first row, first column, and we're going to add that to the first row, first column for matrix B. So that's going to be 2 plus a -1. And then we're going to take first row, second column, and we're going to add that to the first row, second column. So that'll be 3 plus 2. And then we're going to take the first row, third column, and we're going to add that to the third row, first column, and that's going to be -1 plus 1. And now we're going to take the second row, first column, and we're going to add that to second row, first column. So this is going to be 4 plus 5. And then we're going to take the second row, second column, add that to the second row, second column, to the next one. So that would be 0 plus a -3. And then we're going to take the second row, third column, and we're going to add that to the second row, third column of the other one. And so that'll be 7 plus 4. And now we are simply just going to add these together. We get 2 and -1, and that's going to be a 1. 3 plus 2, that'll be a 5. -1 and +1, that's a 0. 4 plus 5, that's 9. 0 plus -3, that's -3. 7 plus 4, that is 11. Now notice when you're adding, this is a 2-row, 3-column. So this is a 2 by 3 for matrix A. And matrix B, this is also a 2 by 3. 2 rows, 3 columns. So that's also a 2 by 3. So we can say that matrix A plus matrix B, that's also a 2 by 3 matrix. So whatever you start with in your matrices, your matrices have to be the same dimensions for both of them, and you're going to end up with the same dimensions for their sum or their difference. Okay, now let's take a look at scalar multiplication. And now let's say we have this matrix A is 1, -2, 2, 0, -1, 3. So what dimensions would this matrix be? You should have said this is 2 rows by 3 columns. So this would be a 2 by 3. 2 by 3. There. Move it over here. 2 by 3. There we go. All right, and now let's say we want to find. Let's say we want to find 4A. So basically, what we're doing here is we're multiplying 4 times each one of these. So we put a 4 here, and we'll just rewrite this matrix here real quick. And so now what we're doing here is we're taking 4 times the first one. So it's like we're distributive property. And then 4 times the -2, so we're multiplying 4 times each term. 4 times +2, 4 times 0, 4 times -1, 4 times 3. And so we end up with 4 times 1, of course, that's 4. 4 times -2, that's a -8. 4 times 2, that's a +8. 4 times 0, that's 0. 4 times -1 is -4. 4 times 3 is 12. And that's our answer. So let's say that we wanted to find 1/2 A. Okay, so now again, this would be 1/2 of each one of these. This would be 1, -2, starting off with matrix A again, and then 0, negative 1, 3. Okay, so this would be 1/2 times 1, and 1/2 times negative 2, 1/2 times positive 2, 1/2 times 0, 1/2 times negative 1, 1/2 times 3, and so we end up with 1/2 times 1, of course that's going to be 1/2. 1/2 times negative 2, that's going to be a negative 1. And then here the 2's cancel, right? And you get a positive 1. And then 1/2 times 0, that's 0. Bring that down a little bit. And then 1/2 times negative 1/2, that's a negative 1/2. 1/2 times 3, this would be 3 over 1, right? So this would be 1 times 3 is 3. 2 times 1 is 2. And so that's your 1/2 of matrix A. Alright, now let's say that we're given matrix A again is 1, negative 2, 2, 0, negative 1, 3. And we'll say that matrix B is 0, negative 2, 3, 1, 2, 1. And let's say we want to find let's say we want to find 3A. Let's say we want to find 2A minus 3B. So I'm deviating from the PowerPoint on this one. Okay, first thing you want to do is you want to multiply 2 times matrix A, which would be 1, negative 2, positive 2, 0, negative 1, 3. And this would be a minus 3B. So this would be 3 times matrix B. And that's 0, negative 2, 3. 1, 2, 1. And we notice that this is a 2 by 3, and this is also a 2 by 3. So we're okay. We can go ahead and work this because when we add or subtract, they have the same dimensions. Alright, so what you want to do first here, what I like to do is to go ahead and change the sign. So I'm going to go ahead and rewrite this whole thing here. Negative 2, 2, negative 1, 3. So only thing I'm doing here is I'm going to change the sign. And I'm doing this just so that to emphasize one thing that's going to happen here. So I'm going to make the minus sign a plus, and I'm going to change the sign of everything inside. So I made the minus sign a plus, so it's like I'm distributing that negative. Make the minus sign a plus. So there's no such thing as a negative 0, so that's just going to be 0. And so the negative 2 becomes a positive 2, the positive 3 becomes a negative 3, the 1 becomes a negative 1, the 2 becomes a negative, and the 1 becomes a negative. Okay, so all I did was change the signs there. Now I'm going to distribute this 2. So this will be 2 times 1 is 2, 2 times negative 2. So this will be 2 times 1, 2 times negative 2, 2 times positive 2, 2 times 0, 2 times negative 1, and 2 times 3. And here this would be 3 times 0, 3 times 2 is 3 times 2, and then 3 times negative 3, and then 3 times negative 1, 3 times negative 2, and 3 times negative 1 again. Okay, now this will be 2 times 1 is 2. 2 times negative 2 is a negative 4. 2 times 2 is a positive 4. 2 times 0 is 0. 2 times negative 1 is a negative 2. 2 times 3 is 6. And then we're going to do the same thing for matrix B, which is 3 times 0 is 0. 3 times 2 is 6. Again, 3 times negative 3 is a negative 9. 3 times negative 1 is a negative 3. 3 times negative 2 is a negative 6. 3 times negative 1 is a negative 3. Okay, so we're finished multiplying. Now we want to take the first, we're going to add these two. So we're going to add 2 plus 0. 2 plus 0, first term, first row, first term, first row, the next one. And then we're going to take the negative 4 plus a 6. Negative 4 plus 6. And then the next one is 4 plus a negative 9. And then we're going to take the 0 plus a negative 3. And then we're going to take the negative 2 plus a negative 6. And then we're going to take a positive 6 plus a negative 3. And so we end up with the 2 plus 0, that's 2. Negative 4 and positive 6, that's going to be a positive 2. 4 and a negative 9, that'll be a negative 5. 0 and plus a negative 3, that's a negative 3. Negative 2 and negative 6, that'll be a negative 8. And 6 plus a negative 3, that'll be a positive 3. And that is our answer right there. Okay. Now we're going to take a look at, move down a little bit here. Alright, we're going to take a look at matrix multiplication. And for matrix multiplication, you have to be careful with it. Here we go. With matrix multiplication, you're going to multiply the first row with the first column. So you're going to multiply 1 times 2, and then you're going to multiply, so you're going to multiply the first row, first column with the first row, first column, but then you're going to multiply first row, second column with the first column, second row. So it'll be 1 times 2, that's this one, and then negative 2 times negative 1, and then you're going to plus 4 times 3. So it'll be 1 times 2 plus negative 2 times negative 1 plus 4 times 3. And so 1 times 2, that's 2. Negative 2 times negative 1, that's positive 2. 4 times 3 is 12. And then you add all three of them together, and you get 16. So let's take a look at another way to illustrate this. Let me go to the next row because I want to make sure I have enough room. Alright, let's say we have matrix A. And let's say matrix A is 1, 2, 3, 4, 5, 6. Alright, and so we can say that matrix A is a 2 by 3. Now matrix B, that is going to be a 3 by 2. And I'll show you why that works the way it does. So it'll be 3 rows and 2 columns. So this is 2 rows and 3 columns, so this will be 3 rows and 2 columns. So this will be A, B, C, D, E, F. So we're saying we want to apply matrix A times matrix B. Now, when we multiply matrices, we need to make sure that the number of columns of the first matrix is the same as the number of rows in the second column, because of the way we're going to multiply them. And then the answer to this will be the 2 outside numbers. So in other words, we're going to end up with a 2 by 2 matrix. Okay, so let's see how this is going to work. We're going to multiply the first row times the first column. So we're going to multiply 1 times A plus 2 times C plus 3 times E. And that's one number. Now what we're going to do is we're going to multiply the first row times the second column, and that'll be the second number. So this will be, we're going to multiply across and then down. So this will be 1 times B plus 2 times D plus 3 times F. And that'll be the second number. And so when you multiply and add all these together, you're going to get a single number here. Alright, now we're going to take the second row and multiply the first column. So we're going to multiply 4 times A plus 5 times C plus 6 times E. So it's second row rather, times the first column. So this would be 4 times A plus 5 times C plus 6 times E. And that'll be a single number in the second row, first column. And now we're going to take a look at the second row. We're going to multiply second row times the second column. So now we're going to multiply across and down for the second row and second column. So this will be 4 times B plus, what do you think is going to be next? You should have said 5 times D plus, and now what follows after that? You should have said 6 times F. Now, because we don't know what A through F is, we won't be able to come up with the single numbers, but this is to show you how the process works. So let's take a look at something that's got all, and notice this would be 2 rows by 2 columns. Each one of these will end up being a single number. So we did end up with a 2 by 2. Alright, let's try another problem. And let's say we have matrix A, and that has a 3, -2, 1, 0, 4, -1. And matrix B, and so we can say that this is what dimension? You should have said a 2 by 3 dimension. Alright, matrix B, this will be 2, 4, -1, 3, -3, 1. Alright, and so this would be what kind of dimension for matrix B? Okay, you should have said 3 rows by how many columns? 2. Alright, so let's see. The number of columns in the first one should match the number of rows in the second, which that do. And so we're going to end up with A times B is going to be a 2 by 2 for an answer. Alright, so we're going to put the 3, -2, a little bit, 1, 0, 4, -1. And we're going to multiply that with, this will be 2, 4, -1, 3, -3, 1. Alright. And so from here, we're going to multiply first row times the first column. Okay, so this will be 3 times 2 plus, what do you think is going to be next? -2 times what? You should have said -1. Plus 1, now what are we going to multiply the 1 with? You should have said the -3. So this would be 1 times -3, and that's going to be one number. Now we're going to multiply the first row times the second column. So this would be 3 times 4 plus, what's going to be next? -2 times what? You should have said 3 plus, what's going to follow after that? You should have said 1 times 1. And that'll be the next number. Okay, so from here, we're going to multiply the second row times the first column again. The second row times the second row times the first column. So this would be 0 times 2 plus, and then what's next? 4 times what? -1 plus 1, -1 times the -3, and that'll be second row, first column number. And then we're looking at, now we're looking at second row, second column. That's a 4 there. So this will be 0 times what? You should have said 4 plus 4 times what? You should have said 3, -1 plus negative 1 times 1. Alright, so now from here we're going to go ahead and multiply and add or subtract. Alright, so this first number is going to be 3 times 2, that'll be 6, plus 2 minus 3. So we're still working on this. Next one, this will be 3 times 4 is 12, and that'll be minus 6 plus 1. And then here this will be 0 minus 4 plus 3. And then here the last one here, this will be 0 plus 12 minus 1. Okay, so one more thing we need to do here, and that's going to be just add them all up. We multiplied, now we're going to add them all up. 6 plus 2 is 8, 8 minus 3 is 5. And so we finally got our first row number for our first row, first column. First row, second row number, that'll be 12 minus 6 is 6, 6 plus 1 is 7. And so that's the number for the first row, second column. Now we have 1 minus 4, so that'll be negative 4, and positive 3, that'll be a negative 1. So this will be second row, first column number. And then the second row, second column number, that'll be 12 minus 1 is 11, and that's your answer. Okay, so that's matrix multiplication there. Okay. Now, unfortunately, matrix multiplication is not commutative. So just because we had A times B does not mean that we can do B times A. So in other words, since matrix A times B does not equal B times A. So we said that matrix, in other words, matrix A, we said that was a 2 by 3. And we said that matrix B was a 3 by 2. So, in other words, the rows have to match up, the number of rows have to match up with the number of columns, because that's the way we're multiplying. Row, column, row times column, row times column. So the number of rows have to match up with the number of columns. So if we were to multiply B times A, this is a 3 by 2, and we're multiplying that with a 2 by 3. Matrix A is a 2 by 3. 3 by 2, 2 by 3. In this case, well, in this case they do, but it doesn't always happen. So we end up with a 3 by 3. But let's say we had a 3 by 4 and a matrix A was a 3 by 4, and let's say matrix B was a 4 by 1. Well, we can multiply A times B is okay. A times B would be okay because the rows number match with the number of columns. But a matrix B, since B is a 4 by 1 and A is a 3 by 4, you can see that number of rows do not match up, or number of columns in B does not match up with the number of rows in A, so we cannot multiply this. So it's possible to be commutative. I mean, it's possible to multiply A times B and B times A, but most of the times that does not happen. And the reason why this happened is because we had same same number. We had a 3 by 2 and a 2 by 3. So it did work here, but it did not work for the second one. Okay, so you want to check your dimensions before you start, because you may find that you can't multiply it right from the very beginning. Alright, so that's all we're going to do for this lesson. We'll do some more in class, and there's still more as far as solving problems. So we'll cover that in the classroom. And so that concludes this video.